Good afternoon, everyone. Welcome. With a quick show of hands, how many of you think that 2024 has been yet another transformative year for GenAI? GenAI has taken the world by the storm. Industries ranging from retail to finance, healthcare are looking at getting business outcomes and better customer experiences through GenAI. Hi, I'm Divakar Bansal. I'm a principal GenAI specialist at AWS, covering EC2 accelerated computing instances, including AI chips-based instances, Trainium and Inferentia. So today in this panel, we'll hear from select customers who are using AWS AI chips, Trainium and Inferentia for their GenAI use cases. I work with companies ranging from startups to enterprises to ISVs and public sector organizations that are delivering business outcomes using GenAI. And they have certain requirements in terms of cost, performance. So I'll talk about what investments we are making in our infrastructure for GenAI. In 2024, we have seen some dominant trends for GenAI. Large language models have become larger. Developers are looking at fine-tuning and adapting those models for better accuracy and better results using domain adaptation methods with RAG, with distillation. And while the models are getting larger with the release of Llama 3 and 405B models, the developers are also looking at smaller models. The new emerging field is small language models. Multimodal models are becoming very common. So as humans, we take multiple inputs, audio, video, text. Multimodal models are trying to replicate that. And then another field, AI agents, Mr. Experts, they are becoming very popular in terms of providing a collective intelligence versus one large monolithic model versus smaller models coming together and providing workloads through a workflow and task-based artificial intelligence. Now, all of this is driving innovation in compute at the infrastructure layer and across the GenAI stack, and we'll talk about some of that. At AWS, we have been investing in AI chips, Inferentia and Trainium for a number of years. The latest addition here is AWS Trainium 2. So if you have been paying attention to some of the announcements that we have made, this week Trainium 2 has been announced. We started with Inferentia a few years ago, Trainium, Inferentia 2. They're delivering great price performance for GenAI workloads. And now with Trainium 2, we're taking that to a whole another level for higher performance for frontier models. Trainium 2 delivers 1.3 petaflops, which is 30% more than any other EC2 instance on AWS. Compared to Trainium 1, Trainium 2 delivers 4 times more compute, 4 times more memory, 4 times more bandwidth for high bandwidth memory. Now, this is our third generation chip purpose-built for generative AI and machine learning workloads. Now, looking at the instance that is built using Trainium 2 chip, altogether, it's 20.8 petaflops of compute in FP8, 46 terabytes per second of HBM bandwidth, and 1 terabytes per second of neural link speed. This makes a Trainium 2 instance our most powerful instance for ML training and inference. What that means for workloads in GenAI spaces, when you're looking at large-scale distributed training, large-scale distributed inference, now you can pack that in one instance versus having to split that across multiple instances. And Trainium 2 is driving innovation by having 30% better flops than any other EC2 instance, up to 95% better memory bandwidth utilization, and enabling 4 times more throughput in sparsity. Again, all of that means that GenAI workloads from hundreds of billions of parameters to trillions of parameters now can work with Trainium 2 in a cost-effective and performant manner. It's also energy efficient. Now, that's just hardware, but hardware alone is not enough. We are building Neuron SDK that provides you tools, libraries, compilers, and framework support to build your GenAI workloads on Trainium and Inferentia. Neuron SDK integrates with PyTorch and JAX as frameworks. It integrates with other AWS services for orchestration, scheduling, and management of infrastructure like AWS Parallel Cluster, Batch, ECS, EKS. Trainium is also available through Amazon SageMaker, SageMaker Jumpstart, as well as Amazon SageMaker Hyperpod. Now, we are also working with a number of ecosystem developers to bring their tools, frameworks, and libraries on Trainium and Inferentia through Neuron SDK. For example, PyTorch Lightning, Ray, Hugging Face is the open source repo for a variety of models. Over 100K models from Hugging Face now run on Trainium and Inferentia. Neuron is integrated with VLLM. Datadog, observability and monitoring. So all these tools provide easy to use and efficient implementation of GenAI machine learning workloads on Trainium and Inferentia. And you'll hear from our panelists on how they're using Trainium 1, Inferentia 2, and looking to use Trainium 2 for their GenAI workloads. With that, I would like to invite Mr. Takeshi Suzuki from Ricoh to share their experience on how Ricoh is using Trainium and Inferentia for their GenAI workloads.
Hello everyone, I'm Takeshi Suzuki from Ricoh Company. Today I'd like to share with you about our experience to develop Japanese LLM. So that with the AWS Trainium 1, and actually we have used this curriculum training or curriculum learning so to get Japanese capability on Llama 3. But well, I think this approach could be applicable for any other languages. So therefore, I think this could be also beneficial for the, let's say, non-English speakers to develop the, such, let's say, language LLMs. So before going into the technical details, let me shortly overview our AI business. And since we conduct, let's say, B2B business, so we have several different services. For example, the AI model training or development, or AI system development, or AI service deployment, all those things. And of course, to, let's say, provide such kind of service efficiently, we have developed our own AI tools. So such like generative AI tools or analytical AI tools. And currently we are focusing on generative AI, of course. And then especially here, I think people are concentrating on the RAG and private LLM. So in Japanese market, the many of manufacturing company or enterprise and financial sector companies, they want to have private LLM because they somehow use very sensitive data. So therefore, we currently focusing on those two, RAG and private LLM. And of course, to provide such service to our customer companies, we need to have very good Japanese capable LLM. And in Japanese market, of course, there are several different technical requirements, and we can summarize it into those three. Oh, sorry, it's 5. And the output quality was really important, and the logical inference is also very much important. But in addition to that, somehow people request us to adapt such LLM towards their specific task. So adaptation for business workflow is also very much important. And of course, they request us to provide it in optimized cost. And sometimes to ensure the data security, they request us to provide service on-premise. So those are market requirements, but to cope with such requirement, there could be major 2 technical challenges. And one is, of course, having good Japanese non-gigantic LLM. So this is quite important, especially this should be dedicated for the industrial use cases. So to do so, for example, the domain adaptation, fine-tuning, and in addition to that, the size of the model. Those are quite important. But not only just about, let's say, LLM itself, but also there are, let's say, requirements for the technical framework to develop such Japanese LLM from English LLM. Because nowadays, most of the LLMs are developed first in English, and then somehow, let's say, localized. And so, you know, every week, every month, we are going to see new model released in the market. So we cannot develop one by one or every time. So therefore, we need to have a technical framework to develop such Japanese LLM from English LLM. So that is also yet another important aspect. So our solution can have 2 steps. And the first one, if there is no available Japanese LLM in the market, we need to develop by our own. So tokenizer adaptation or tokenizer optimization plus curriculum learning. This could be quite efficient and important way to develop such a localized LLM. And the international model or multilingual model could have multilingual tokenizer, but this is not optimized for specific language. So therefore, the total performance or total efficiency of the LLM is quite low. So therefore, we need to somehow adapt and optimize such tokenizer to specific language. In this case, it's Japanese. And curriculum learning. And you can see that the three different phases and the objectives for first and third phase, that is quite clear. And the first phase, the objective is to minimize the catastrophic forgetting. So therefore, we adapt much amount of English corpus, so to avoid such forgetting. And the last part, the third phase, that is also important to manage the quality of output Japanese sentence. So therefore, we put highest quality Japanese corpus as much as possible, while minimizing the English corpus. And the second part, that is a bit tricky, and the enhanced robustness of representation. This is because LLM is not for single task or single purpose. There are different downstreaming tasks. So therefore, we need to have very robust language representation inside. So to develop such representation, we conduct much amount of, let's say, cyclic training there with a much amount of corpus. So that is the way that we get the top-class Japanese capability while preserving English capability. So second step, when the baseline LLM is available in the market or in our company, so that, again, tokenizer localization or Japanization is also required. But in addition to that, model merge technique can be applied to get higher, better performance. And in this figure, you can see that yellow square, Llama 3 Swallow, that is a Japanese LLM developed by Japanese academia, Tokyo Institute of Technology. And this can be a good base for the further development. And in addition to that, we can calculate chat vector from meta model and chat vector from Ricoh model. So combining those three with some weighted sum, so we can get really high performance Japanese LLM. So the resulting one could be on rightmost that has a GPT-4 equivalent as a performance in Japanese. So to develop such LLM, Japanese LLM, of course we use the TRN1, Trainium 1 framework, or let's say large scale cluster. And to identify best setup for us, we have conducted exhaustive experiment. And you can see right-hand side, number of nodes versus the throughput. So with that, we can identify best sweet spot for us. And in this case, 256 nodes. This is the best for us for the optimizing the cost and the performance. And with this setup, we achieved that, for example, comparing with GPU cluster and lower training cost up to or by 50% and shorter time by 25%. But at the same time, you can see the middle. The last year, 2023, we developed Llama 2 Japanese model, 13 billion model. And at that time, just 45% cost reduction and 12% of the shorter training time. And you can see that as we gain our experience with Trainium or SDK, we can get better, let's say, feedback from that. So always there are problems and challenging, and we have used this SDK 2.19 for development. So one of the risks that we need to state here is that such kind of SDK is quite important for developers, but for example, this 2.19 was first available, alpha version was available in May, but the GA in July. So we cannot foresee such kind of scheduling. So to avoid this kind of risk, we need to communicate with AWS developer tightly so that we can understand how and when it is available for us. And in addition to that, node failure is always a problem, I think not only for us, but also for you. But there are several different countermeasures. So to summarize this, the infrastructure error is unavoidable, but there are some countermeasures. So we have been collaborating with AWS for several years, and starting from the small version, 6 billion model. Now, in this year, 2024, we have developed two versions of the 70 billion model together. And from now on to 2025, we are going to concentrate on developing the large-scale multimodal model. So this could be based on Trainium 2, the framework, and I expect that the further improvement of this development time and the lower cost of, let's say, development. So anyway, with this, we are going to seek for the best adaptability for our customer companies. Okay, so that's it. And so please welcome to the next speaker.
Hey everyone, you hear me good? Good voice. My name is Mark McQuaid. I'm the CEO and co-founder of Arcee AI. Arcee AI, we've focused heavily on SLMs, smaller specialized language models. And I'm just going to talk a little bit about how we were able to reduce costs for training and inference utilizing Trainium and Inferentia. So just a quick overview on us. Founded in 2023, a Series A company backed by investors such as Emergence and Flybridge, Long Journey Ventures. We create SLMs, as I mentioned. So we have a world-class post-training pipeline where we've created some of the most unique libraries in the space, specifically model merging. We have a library called MergeKit, Spectrum, which is for efficient training, and model distillation. We have a library called DistillKit. So we utilize all these libraries from within a pipeline and an API to create these models. Some of our partnerships, obviously AWS, Hugging Face is a big partner, MongoDB, and some of the models here listed. You know, we have some of the top models on the Hugging Face leaderboard. The best 1.5 billion parameter model, one of the best 70 billion parameter models, best Arabic model. Yeah. So a little bit into what we're doing now. So we've kind of transitioned from toolkit provider to model builder to now end-to-end system company. So now we're 3 days ago, we launched our new product called Arcee Orchestra, where we're now delivering purpose-built AI agents with our SLMs. Okay, so it's more than just the model layer. And we supply this end-to-end agentic system that we call Arcee Orchestra, really to enable businesses to complete and automate tasks to deliver, to drive ROI, as opposed to just delivering a model and having no real insights into how they're going to utilize that model. So what are some of the challenges when you're deploying, deploying SLMs at scale? Cost. So one of our flagships is efficiency. We are all about efficiency. We're all about cost savings. And our software is designed and built to lower cost of model training and model inference, obviously not just because they're smaller models, but because of the way we train them and the way we deploy them. Performance. So obviously we're all pretty familiar with NVIDIA GPUs and the performance you get, but a lot of times that is not cost effective and efficient for the performance that you're getting from a model, whether it be training or inference. Efficiency, as I said, we're all about efficiency. So this is what happened. We started to look for new hardware opportunities to be able to efficiently train and then again deploy models at a lower cost than you would typically on NVIDIA GPUs. And it all boils down to cost performance. So we decided to utilize Trainium and Inferentia, work very closely with the Annapurna team to better serve our customers with more cost-effective and readily available chips as opposed to GPUs. So optimizing the cost performance, right? So we're lowering the cost associated with the training when utilizing Trainium as opposed to NVIDIA, and inference as well. Of course, availability, I'm sure everyone's familiar with GPUs are a scarce resource within AWS at times. Trainium and Inferentia chips are more readily available and more available in more regions. And the complexity of deployment. So we tried to minimize that as much as possible. I think everyone is familiar with deploying to NVIDIA hardware, NVIDIA chips, but trying to also minimize the deployment effort when moving to a different chipset. Yeah, so we worked, as I said, very closely for months with the AWS team, and see if this pops out. We built several best-in-class, Llama-based SLMs, working with that team using Trainium for training. So, doing continuous pre-training techniques on top of Llama, and then we produced a model called Supernova, which was our flagship 70 billion parameter model. We've since released a new model called Virtuoso, but also our Medius model, which is the top 14 billion parameter model on Hugging Face right now, and Supernova Lite, which is an 8 billion parameter model. As I said, we worked with AWS to evaluate all our SLMs, how they, the training runs on Trainium and inference on Inferentia. We have all our models now listed on the AWS Marketplace and in SageMaker Jumpstart, all available to be deployed, via one click onto Trainium or Inferentia for inference. And we also validated a lot of other things, and Trainium and Inferentia really stood out in the things we could capture out of those chips. Now, speaking more specifically to our platform that we just launched 3 days ago, I had mentioned, Arcee Orchestra. This is what the stack looks like. So you see the agentic network. Those are our SLMs. That's the model layer, but we've building on top of that model layer with the model routing and orchestration and the task decomposition, the front end UI, API. But that entire agentic network of models is now, we trained them on Trainium and are now deployable onto Inferentia. So the results, better cost performance across all our model sizes. So you can see on our 8 billion parameter model for inference, 32% better, more cost effective than running on a G5 2 extra large, which is obviously a small GPU. And then our 70 billion parameter model, that's when you start to get up, extremely cost effective when compared to the P4D, the P4DE, and the P5 when deploying these models to Inferentia. Again, better region availability, more scalability from within these chips, and the one-click deployment out of the AWS Marketplace right from into SageMaker Jumpstart, and the Bedrock Store now. So what are we doing? What's our road ahead? We're going to continue to work with the AWS team and continue to validate architectures, ensure that everything from SLMs are easily able to be trained on Trainium, deployed on Inferentia. We're a design partner of Trainium 2, so that should also increase the performance and cost benefits when doing training on Trainium. And we're going to continue to collaborate there. And as I said, all our models, which I believe we're at about 13 or so models now, are all on the marketplace, all available to be deployed onto the Trainium and Inferentia chips. Thank you.
Thank you. Arman, it's a pleasure to have you on the stage. Let's get started with your quick introduction for the audience.
Yeah, absolutely. Thank you so much for inviting me. It's my pleasure to be here. I'm Arman Ruiz. I'm the VP of AI Platform Product Management at IBM. And yeah, we are doing a lot of work with AWS, and I feel we're just getting started.
Yeah. Can you tell us about what products and services IBM offers? And I know there is a lot of GenAI focus at IBM.
Yeah, so I'm sure many of you remember IBM Watson. So we released May last year, our next generation of Watson platform with a big focus on generative AI. It's called Watson X. So as part of that Watson X platform, we have like three core components, just to simplify. We have an AI studio with all the tools and models and all the capability to go crazy and create your GenAI solutions. Then we have a Watson X.data, which is our intelligent data lakehouse, basically bringing together all the data, metadata, in order to connect the data to the AI, which is a big component still. And then governance, which is a core component we're going to be talking about, how you actually monitor, govern, make sure you have observability, compliance on all your projects that you put in production.
That's great. So what are your views in general on GenAI? As I mentioned earlier, I think 2024 has been a transformative year yet again, right? There are lots of new compute options, there are new frameworks that have come out, there are new model types, new categories, and so on. So what do you think where we're at today and where we'll go from here?
It's been a blessing because I've been working in AI for over a decade, and I was feeling we were in this AI winter. Things were not moving, and then finally, OpenAI did the marketing we all needed. Right? They show a very cool application, and then everybody saw the potential of AI. It was kind of taking the world by storm. So at that time, I was in a pre-sales team. I spent most of my career in product management, but I did like a quick time in pre-sales for 2 years, and then we just hired 500 AI engineers, and we did over 1,000 pilots on Gen AI, and it was incredible. And I think this chart summarizes a little bit how I see the evolution of what's going on in the market. If you see from the top, we started all becoming prompt engineers and prompt experts, right? We had these LLMs, and we were trying to engineer what was the best way to go and prompt these amazing models, and then try to get an outcome. And then we started to figure out things like adding more context to the prompt, add more data. We had a lot of issues with context window, but at the end of the day, we were getting a lot of problems with hallucinations and things like that. Then we went to the second phase, which is what I like to call like the evolution from fixed flows to variable flows. So everything that is a fixed flow, we could basically ground these LLMs with data, with the classic RAG kind of use case. Actually, when I was in this pre-sales role that I mentioned, we did almost 90% of the projects were RAG use cases. So how you can take a good SLM, I'm a big fan of SLMs, and adapt them and ground them with your own enterprise data. And now we're in the middle of the biggest shift, which is the most exciting one, I think, where we're going to fully automated end-to-end AI systems that are not fixed. They are not fixed flows. They are variable because the LLMs are actually making all the planning and all the reasoning and updating and coming back and having this feedback loop.
Great. So one of my favorite moments from 2024 is I attended a conference earlier in the year where the authors of the Transformer Attention is All You Need paper were all on stage. And they were talking about how the transformer architecture originated and what are the new options, new categories of models that can emerge from here, right? Non-transformer based models, agentic AI, reasoning, and so on. And I think you kind of touched on that. Do you have any views on reasoning, and what does agentic AI actually mean, and what potential does it bring to the AI ML developers and use cases that opens up?
Yeah, I think in terms of use cases is where we're going to see a lot of innovation. We're already seeing that, actually. We are moving from like AI that can generate an outcome to an AI that can actually take full action. It depends on how comfortable we are to give those superpowers to the AI. Yeah. But in order to do that properly, these models they need to take it to the next level. So that's why there is a lot of innovation going on in all the research labs, our included, and IBM research on things like smart planning, reasoning, and things like that. And there are starting to appear a lot of leaderboards and benchmarks that they don't measure just accuracy in different knowledge tests, but also in things like reasoning.
Great.
So that's going to be really key as we are integrating, moving into these agentic kind of workflows.
Great. And then what I feel excited about for AWS is when we partner with companies like IBM, right? It drives the innovation at AWS in terms of infrastructure capabilities that we need to build to support all of what you just said. Now, the use cases for Gen AI are growing, and so is the demand for compute, and that needs to happen in a very cost-efficient manner, and energy efficiency is a big thing. And some of the things that I talked about actually address those needs in the market, and we'll hear more on that. Now, you touched a little bit on the Watson X product, right? But I also know IBM has been investing heavily in building own foundation models, Granite, and so on. Any views on that in terms of what these models do differently from others?
Yeah, so, well, first of all, we've been training models for over a decade. When transformers came in, we already were training our own transformer models, and we released a family of models called Granite with the latest generation announced last month, actually, with a lot of interesting capabilities, but really focus on enterprise and making enterprises very comfortable at using these models, making sure we actually disclose the entire data set. So you can go to the white paper and see every single data set that was used for pre-training, for training, how we generate data as well. So all that is disclosed, fully open, all with the right copyrights and legally checked. So that's making companies in specific industries and regulated very comfortable at leveraging these models, because most of the other providers are just providing this black box and you don't know what happened there. And then full indemnification as well, which also checks the box for a lot of use cases, especially in financial services or insurance, for example. So, and then also being state of the art, open source, and providing the weights, so you can go take them and modify them. So we've been very excited about that. We partner with AWS on many different angles. We partner with a lot of different companies. One of the most exciting partnerships that we have is with AWS. I think you are, and this is something I say honestly, the number one hyperscaler out there. And we have a lot of our customers with a lot of data and workloads on AWS, and they love our software. So it's a perfect marriage between your infrastructure and your cloud and our software, and we're bringing pretty much all our software we can as fast as possible to AWS.
That's great.
And our granted models are available on AWS as part of your services.
That's great. That's great. Yeah, we have recently made them available through Bedrock, and there's more coming.
Yeah,
I would say that. Now, talking about research and the infrastructure and everything else, I want to get your views on infrastructure options.
Yeah.
Obviously, there are GPUs, other accelerators, and then AI chips. Especially some of the ones that I mentioned earlier from AWS are becoming an important part of solving this puzzle of Gen AI performance and compute and so on. So in general, what do you think the role that AI chips can play in this field, and specifically AWS AI chips, what do you see?
Yeah, so obviously there are the two parts of the equation, right? There is the training or tuning and then the inference. I'm particularly more excited about the inference, everything that we're doing on that front. Even though training is important, I think more and more we'll have companies doing tuning, especially with services like yours that is lowering the cost and making it simpler with all those frameworks and libraries. But inference is really where I think it's at. We're gonna see like so much demand and workloads. And at IBM, we're helping customers move from this pilot stage into full production and impacting millions of their users and customers. So we needed a partner that can help us make sense of this technology for our customers, lowering the cost, provide very good latency and high performance. And at the end of the day, AI is still all about the data. So a lot of the customers, they are storing the data on AWS. So having the best chips with their data all in the same infrastructure, in the same region, it makes total sense. So in Watson X, we are just working together with AWS to make all our entire stack to work natively with your chips. We announced partnerships with other vendors. We're kind of like very hardware agnostic in our approach. But when it comes to public cloud with AWS is where we're doubling down.
Great, glad to hear that. So I'm actually working very closely with your teams on getting Granite models, working with our AWS Neuron SDK on Trainium and Inferentia, and also the integration of Watson X on Neuron SDK and Trainium and Inferentia. So very excited about the partnership. Now, what's next for IBM in the Gen AI space? Where do you think IBM is going in particular, and the state of the industry?
I mean, I can tell you I'm spending 99% of my time on agents and full stack. I think these agents are going to completely change everything. So it's been this evolution that I mentioned. So going from like these systems, agentic systems will interact with many different LLMs and SLMs, and how to optimize that stack so it's cost effective, how to orchestrate all these agents working in together, and then providing a lot of good tooling. One of my obsessions is all about how you run and manage, and we do have as well a partnership with SageMaker and our governance part of the portfolio. So you can train models in SageMaker, put them into production, and then we have our stack to monitor and manage and run them at scale. So I expect companies to have millions of these agents in production, trained with many different tools, Salesforce, Agentforce, Copilots from Microsoft, with your services from AWS, with open source frameworks. So we're bringing all this together to run them and manage at scale. So that's where I'm spending a lot of my time right now.
Great, great. And I'll have you back on stage for Q&A, but any final thoughts for the audience?
I mean, I think I've been asking everyone to get started with Gen AI. I think right now is a perfect timing as well to get skill on agents. Just learn what it is, learn about the use cases, and then get started with some of the simple applications. If you know how to code, just take one of these very popular open source libraries and create your own agent for your personal use case. It will blow your mind. And then if you like no code, there are a lot of no code solutions as well that will allow you to create your first agent. And then once you create your first one, you'll see the potential, and 10, 20 more use cases will come to mind.
Yeah, and I'll do the plug for Arman. I'm a big fan of his LinkedIn posts, and he does post very regularly on agentic AI's reasoning and so on. And you have a 15-day course, right? That one could take to go step by step understanding Gen AI and start coding without actually coding for Gen AI. So.
Every morning at 7 a.m. I post on LinkedIn something educational about AI.
You're doing great work.
That's been interesting. All right.
Thank you.
Thank you so much.
Wong Peng, good to have you.
Me too. How are you?
Doing well. So tell us about yourself.
So basically, I'm a multimodal developer around 2 years, and previously I worked 1 year on audio processing and 5 years on image and videos. Currently, I'm mainly focused on develop a multimodal large language model for TikTok. So the model is called MASP, modality as soft prompt, and currently it is already begun to generate tons of revenues for the ByteDance. And that's all.
Great. Can you tell us a little bit about ByteDance, your company? What do you guys do?
So basically, we are sharing multimedia, videos, text, some news, like this.
Okay, great, awesome. So I'll ask you the same question that I asked Armand. What are your views on Gen AI, and what are the biggest use cases, and where do you see the most potential?
Yeah, so for generative AI, I think comparing with the perception-based AI, it is mainly to empower the individuals. So basically, it can help you to enhance your coding and or drawing some pictures. So basically, individuals' power, the end user is people instead of some cameras. So it gives the power to the people itself. Yeah.
Oh, great. And just to remind the audience, right, we talked about 4 major trends: LLMs, SLMs, multimodal models, and agents. So Wong Peng here from ByteDance is focusing on his experience both from research as well as his company using multimodal models for generative AI research. Yeah. Right. So with that, Wong Peng, can you tell us a little bit more about what are multimodal models, actually?
So basically, it mimics what human can do. Human have eyes, and 70% of the information from the eyes, and human have ears. So the multimodal input is same. It has images, videos, and also audio signals. And output can be some pictures, videos, and natural languages. Yeah, so for the multimodal, I think the next breakthrough would be it probably can incorporate with agents to automatically generate some high quality annotations, because data currently, I think it is still highly relies on human to do some annotation. But if we can solve the annotation problem, have high quality data endlessly, I think AI probably have another breakthroughs.
Got it. And what are some of the challenges in deploying multimodal models, or just generally developing, training, fine-tuning, or deploying these models?
The challenges, I think it is because the model is quite large, model is quite large, and we actually don't want to do much sacrifice for the performance accuracy, like quantization. We want it is to be online in the highest performance, which need thousands of GPUs and like this, or AI chips.
Got it. Got it. So you touched on what these models are capable of and what are the challenges, but what do you think are the main use cases where these multimodal models can shine?
So basically, I say it can be used in almost all our business lines. I mean, it is actually can at least perfectly replace the perception-based previous model. Yeah.
Okay, great. So can you tell us about your experience of using multimodal models with Trainium or Inferentia and Neuron SDK?
So basically, we use the Inferentia tool to deploy it globally. It achieved around at least 20 more percent throughput than the NVIDIA GPUs, and also with a cheaper price. Yeah, at least 13% cheaper. Yeah.
Got it. So, so basically, high performance, cheaper price, and global availability
Yes.
is what drove you to select Inferentia 2.
Yes.
For our GPUs.
Yeah.
Now, in terms of using Neuron SDK, which is the software stack, do you have any experience or opinion that you want to share?
Yeah. So although finally it is cheap and faster, but I think the initial experience is because it's we initially have some difficulties, but we work together with the AWS engineers to solve those challenges, like how we convert the Hugging Face model to the neural format.
Yeah.
I think recently I heard that there are new libraries like Nikki can help to convert the model like this.
Yeah. So since you mentioned Nikki, I will explain it for the audience. Nikki stands for NKI, a neuron kernel interface, which is basically one of the ways you can use Neuron SDK to develop kernels on your own. It's one of the very sophisticated features, requires deeper understanding of the hardware architecture as well as the software and the custom operators that the machine learning offers. But there is a feature called Nikki that you can use to develop your own kernels. Now, you talked about performance, you talked about your experience on Inferentia 2. I'll come back to multimodal models, right? The space is quickly evolving, and we heard from other speakers as well that the Gen AI portfolio with trends and everything is quickly evolving. What are your thoughts on multimodal models and what's going to happen in maybe the next 2 or 3 years?
Yes. So I think currently we can solve the natural language and single or mountain image very well, but for the videos, it is actually have spatial and temporal information, like I think like a Fei Li's company, Spatial Intelligence. It is the video is actually have one more extra dimension, time, spatial and time. So basically, I think it's at a very initial stage of the video understanding. If we can understand the video very well, like a GPT moment, then I think it will would be the brain of robotics. And the robotics, I think there should be Apple-like company for robotics, which can interact with the real world, help us to solve a lot of problems, like ourselves. So basically, AI is actually, I think, is a reproduce a human.
Yeah. All right. So there is a lot of possibility in working with different modalities and video, text, images to increase the perception, right?
Yes.
And that opens up. Now, one of the things that you touched about Inferentia 2 is the availability and price, performance, and so on. I know a company like ByteDance, the scale could be massive, right? Can you give us a sense for what that scale is, and is it like?
So basically, we handling at least billions of inference each day.
That's impressive.
So some multimedia video like.
Okay, great. So any final thoughts, Wang Peng, before we call everybody on the stage to answer some Q&A?
I think finally AI would be benefit to all the human. So as long as it is for almost for everyone would be good
Yeah, no, that's a very noble and a great vision, Wang Peng. I think we participate in this together with a company like yours to make it accessible and scalable
Yeah.
using the infrastructure that AWS has and the technology that you all bring to the table. Now, I'll just quickly do a recap of where we are at. In this session today, we talked about some of the emerging GenAI trends in LLM, small language models, domain adaptation, distillation, multimodal models, MOEs, and agentic AI techniques that are trending in the GenAI space. Now, we also heard from our customer representatives who are using AWS Trainium and Inferentia instances to deploy GenAI workloads and deliver better performance, better price, and innovation at a scale that's not possible with other compute options that are out there. Now, we'll use the next 10-15 minutes for Q&A, and I want to split that in two parts. First, I want to ask some questions of the speakers that popped up in my head when I was listening to their presentation. And then secondly, we'll get off the stage, and then if you have any questions, you can take off your headsets, and then we'll entertain those questions for 5 to 10 minutes. So I'll welcome everybody. So great presentations, everyone. Thank you for being here. My first question is to Suzuki-san. Now, you talked about Japanese language adaptation of LLMs, right?
Yep.
And I know you're solving a big issue for low resources languages, and language models are generally not trained for other languages than English, although that's changing, right? So where do you think that space is going? Do you see that to be a continued trend, or do you think that problem is going to be solved by foundation model builders? So companies like Ricoh who are building solutions don't have to invest in that, right?
Right. I expect sooner or later, I guess the OSS models or proprietary models will cover multimodal, right? But unfortunately, for example, tokenizer, it has some specific limitations. For example, the vocabulary or some, let's say, efficiency or let's say tokenization efficiency or something. So therefore, it cannot be focusing on specific language. So therefore, anyway, there could be still remaining requirements to adapt such model toward a specific language. So that is just my guess. Yeah.
Got it. One more question for you. So I know in your presentation you also talked about distillation and agentic AI and reasoning. Can you allude to some of that? What does distillation actually mean, and what's happening there?
All right. So today I just talk about the larger size model, like 70 billion or bigger than that. But as the other speaker talk about SLM, so there are always strong requirements for the market to make smaller, better model, right? So there are different ways to do that, like a quantization or something. But distillation is one of the very promising techniques. And actually, for example, the recent Llama 3.2, so that is developed by distillation. Like a 3 billion model or a smaller model is distilled from the bigger size model. So it is quite promising model, promising technique. So therefore, I think many companies, including us, would use it from now on.
You got it. Got it. Great. So my next question is for Mark. Mark, you opened up about SLMs, and you are the pioneers in training, fine-tuning, deploying small language models, right? What's next in this space? How small these models can be while still maintaining the accuracy and the adequacy of the function that they need to do?
Yeah, it's a great question. I don't think we know yet, but I think the goal is to keep getting smaller and smaller and stronger. So, I mean, we've got some great models that are 1 to 3B that are for device. That's the next kind of big thing. Get those models humming on devices. Apple Intelligence obviously is I think 3 or 4B, and if you can get them down to run on a cell phone and be as powerful as potentially one day getting those models to be 32B capable, a 70B like capable, not the size running on device, but like a 3B with that kind of capabilities. I think that's the next wave, the next frontier. And yeah, I mean, it's I think there'll be an area where the closed source providers keep making those big models, and then open source keeps kind of
Yeah.
trimming them down, and it'll just be a good battle.
That's great. And I would imagine when it comes to agents, right, when you're looking at these tens or hundreds of these models,
Yep.
those models have to be smaller so they can collaborate and
Yep.
build a combined intelligence versus
Exactly.
depending on one monolithic large model for a task, right? So
Yeah.
it's important to have smaller models and to enable that field as well. What are your views on that?
Yeah, the way we have it positioned, our orchestra system, right? So you can imagine a collection of smaller models in a mixture of agents architecture. You have a router, then you have one head model. We used to call it Swarm, and then OpenAI took the word name Swarm, but we called it Swarm before they did. So we had you have a head model. Let's say it's 32 to 7 dB. Okay, this is a general model. Underneath it, you fill the gaps. So you have a 7B function calling model, a 7B coding model, a 7B SQL model, an advanced reasoning model. All those 7Bs, in theory, can run on CPU. They don't need GPUs. So you could run on, obviously this is a Trainium and Inferentia, but you could run on Graviton.
Yeah.
Pennies per hour. And those can power 80, 90% of your SLM agent workflow. So the cost savings are tremendous. And if you have those specialized models that are filling the gaps, you don't feel the pain of just comparing a 32B model to a Claude Sonnet 3.5.
Got it. Got it. I know you were nodding your head, Arman, on that question. So I would
I
like
mean, look, I've been talking about SLMs. Like when ChatGPT went out and everybody was talking about like super large models and who's going to have like the largest and most powerful ones. At IBM, I was really like talking about SLMs all day long, and nobody was really paying attention. And then these guys came around, and as a startup, they were moving faster than IBM and shipping things quicker. And now the market is completely going into that direction, especially with multi-agentic systems. And then you just imagine the power of all these smaller models running on device on our cell phones that they are like order of magnitude of like 100x or 1000x more than laptops. It's just gonna be crazy. So what they are doing is really amazing, and pay attention to SLMs, small models that are very narrow for a good task, and something we didn't really mention I think much is about good evaluation frameworks, because it's all about that. It's a lot about testing those models with a good evaluation toolkit. And just making sure those models work for your specific task. You don't need a model super large that can do 1,000 different things. They need to do like your one or two things very well, and most likely you will have a collection of them and orchestrate them.
Great. And I think we love the partnership with you all in terms of pushing the innovation also on AWS side, both at the chip level and the infrastructure level, as well as software, because everything that you desire from us helps us build those capabilities in the chips, in the Neuron SDK, in the infrastructure. So with that, I'll go just one more round and ask for your final thoughts on AI chips, Trainium and Inferentia, starting from you, Arman.
So I think it's time to get ROI from AI, and just paying attention at the cost as you move into production is important. So that you need to be picky on which infrastructure and chips you are running your AI as you do that transition from like all these pilots into production. So on that sense, I think you guys are bringing to the market very powerful set of capabilities.
Perfect. Mark?
Yeah,
Same question.
Echo that. If we can, enable companies, customers, users to run AI workloads outside of NVIDIA hardware, that's a benefit for everybody. From cost, performance, just overall distribution of the market. You never really see in the market one company win completely, right? So there's time now to catch up with these other chips, and with the lack of availability of NVIDIA GPUs at times, and those are all things that should help the case for Inferentia and Trainium chips. And I think just the engineering teams just need to keep cranking and keep up. Right? That's the thing. You got to keep up.
Yeah,
but
keep the pressure on us.
Yeah, exactly. And I think the sky's the limit.
Cool. Suzuki-san, same question.
Yeah. Actually, today we just talk about, at least I talk about LLM, but nowadays I think the multimodal model, as he introduced, is getting more important, right? So therefore, much more different data sources, data streams need to be considered in training or inference. So therefore, I think the requirements for the better hardware or training infrastructure could be still keeping up. So that could be also the keeping trend this year, next year, or some years, I guess. So maybe that is also a wish from my company
Awesome.
that we can also utilize such a strong capability of let's say training to get better performance LLM or LMM. Yeah.
Wonderful. Wong Peng, same question for you. Final thoughts on Trainium and Inferentia.
Yes.
What would you like to see?
So I think it's basically like previously gold mining. It is a two side. It is a must have to do the gold mining, and it is actually at the early stage of the AI. I think so. Basically, the two side would be I think the necessary would be 100 probably 200 times than current we have. Yeah. So we just begin the AI probably. Yeah.
Great. Awesome. Thank you so much, everyone.
Thank you.
I think I learned a lot from your presentations, and I'm sure the audience did too. We'll get off the stage, and then you can ask questions of the speakers. Thank you.